This is the video of our project, the digital twin of a lean drone assembly line, including the automated drone assembly line, the control logic, the mechanical simulation, and the FMU concept.
Hello and welcome by the production line of drones, digital twinning semester 7. So our design at first, we have a station 1. Station 1 will bring pallets on the whole system. So they will be working on pallets. The lift will go up with the pallets. The cylinder over here will push the pallets on a conveyor belt. And when it's here, there will be a sensor that detects the pallets and it will go up, bring the pallet over to the main conveyor, and it will put down. When it's on the main conveyor, there will be sensors over the lifting table here, lifting table here, and lifting table here. Those are the three stations: station 2, station 3, and station 4. And the main conveyor belt, so the whole conveyor belt, will be the main code, which will contains the three station tables and also the station table of station 1. So at first we will simulate the station 1, which will have the lift and the cylinder to push the pallets on his own conveyor. So that will be over here in the program. Start the simulation. So there will be two sensors. They will detect the lift. So there will be a pallets on the lift. Then this will go up. And when this goes up, the lift will go up in 5 seconds. And when it goes up in 5 seconds, there will be a detection sensor on the top of the lift that will push the cylinder out and will stop the lift as well. So when the pellets reach the top, the lift will go out. Sorry, and when it goes out, the pellet will be pushed by the cylinder and will immediately go back. So I will show you again. When the sensor is out, the pellet will go up, and when it's up, the pellet will be pushed on the conveyor belt. So when it's on the conveyor belt always goes forward. But if the sensor at station 1 at the end is high, then it will stop. When is the yeah, I can show it over here as well. So now it's true, it will stop, and over here the switch table will go up, and the conveyor of the switch table also will go on. And when it goes on, it also will lifting the switch table of the main conveyor. So we can go back to the main conveyor. This is the auto state. Then we go back to the main conveyor. So the sensor is still true. So the switch table is on, the conveyor of the switch table is on. In eventually the pallet will be seen by the second sensor. When that happened, this will go true. Then those will go down. This will be false because there's no pallet there. And then it will give a bit to the main station, to the station 1 again. Eventually it will go out and the pallet is on the main station. So that's it for station 1. Then we go further. The main conveyor will be moving as well, and that will be declared over here. So it's true. There are many states because one of the states is sensor 2 for the station 2, station 3, and station 4. And those also has a handshake. So when the handshake is done, the conveyor belt will be moving. Otherwise, it will stop. So we can go back to station 2. So if we are station 2, then we go over here in the project. Station 2 is a gantry system. The gantry system already picked up the frame, so it will picking up the frame. So when we go over here, it will go left. There will be there will be a pile of frames. The frames will be picked up and will be placed on the pallet, and then it will go further on the production line. So that's the function of station 2. So right now we are at the second station, which will see a gantry system. The gantry system have 4 sensors that will be left up, left down, right up, and right down, and it will react on the sensor of the station, the main conveyor, which will be the detection sensor of if there's a pallet or not. So right now, the sensor is on the right down side. That's because it already has picked up a frame. So when the pallet's over there, it will move back to the frame position, and also doesn't grip anymore and will go back in. So when it's moving back in, the sensor will go out, and it will still move to the frame position, and the cylinder is in, so the sensor of the laptop will go on. So when it's on, the cylinder will go out, and now it's on a left down position. So I will turn this off and turn this on. So when it's left down, it will grip the system, and it will move the pallet to the right top position. And also it gives a handshake to itself because it's ready to drop the frame on the pallet. Right now, because this will be off probably. So right now it's on the right top position because the cylinder is in. So it will be this one. It will go up. This will be down. So it will go out and it will wait. It still grips. It will wait. It will wait at this position, and when the table is there, the frame will be dropped. So now we're going back to the main. And in the main, there's like a handshake from station 2 to the main. And there's a sensor that detects the pallet. So when that's true, you also see function done because it's dropped to the main conveyor belt, and the switch table will go down. Now the conveyor also will go further, and now the sensor of the object is false because it's further on, and the object is still done. But that's because I didn't move the sensors yet with the simulation. So right now it's still down. It doesn't grip anymore. So when I go back to the position where it goes to, because moved to the frame position, cylinder was off. Now it's on, so the cylinder will go back left down, and it will be left down. Right at this moment, you will see in the main also that the handshake, the function done, is also false. But when this up, still function done is still false. So the handshake to the main is still false, and it will give like a handshake to the station 2. So handshake main to station 2, and it will say like the table will be on, but it isn't ready to pick up yet because of station 2. So this system.
This part of the video is a demonstration of how the drone assembly line operates in Siemens NX Mechatronics Concept Designer. The assembly line consists of a main conveyor and 4 sequential stations, each performing a specific task in the drone assembly process. At station 1, an empty pallet is introduced into the system. A horizontal pneumatic piston pushes the pallet forward, and a vertical piston lifts it on the height of the main conveyor. Once the pallet is aligned with the conveyor, it is transferred onto the main conveyor and transported downstream. The pallet then moves toward station 2. When the pallet reaches the station, a sensor detects its presence and the conveyor stops. At station 2, the pallet platform is lifted to the working height. A gantry-based pick-and-place system retrieves the drone frame from its supply position. Using a suction-based gripper, the gantry places the frame onto the pallet. After the placement is complete, the platform is lowered back to the conveyor level. The pallet is then transported to Station 3, where a similar sequence takes place. At Station 3, the pallet is lifted again, and the gantry system sequentially places the propellers onto the drone frame. Once all the propellers are installed, the platform is lowered and the pallet continues to Station 4. At Station 4, the battery is placed onto the drone using the same gantry-based approach. After the final operation, the pallet exits the production line, completing one full assembly cycle. Throughout this process, the mechanical movements, sensor activations, and actuator responses can be observed directly in the NX simulation. And now the video will continue with more drones being assembled.
Well, now in this part of the demonstration, the interaction between Siemens NX Mechatronic Content Designer and Siemens TIA Portal is presented. The PLC control logic is executed on a virtual PLC created using PLC Sim Advanced, which allows the control program to run without physical hardware. The mechanical model in NX is connected to this virtual PLC, enabled signal exchange between both environments during simulation. While the simulation is running, it is possible to observe how changes in the mechanical model are reflected in the PLC program. When a sensor is activated in the NX model, the corresponding signal changes state, and this change can be monitored directly in TIA Portal, where the signal switches between true and false. By observing these signal transition, the communication between the mechanical simulation and the PLC logic can be verified. This confirms that the NX and TIA Portal were currently linked and that the signal exchange between both environments is functioning as expected during the simulation. The rest of the video will continue showing how did we saw the connection between the signals on the NX and the signals in the PLC program. In addition to the mechanical and control simulation, a functional mockup unit or FMU was developed as a part of this project. The purpose of the FMU is not to directly control the assembly line, but to represent a performance-related effects such as congestion and additional delays in the production process. The FMU receives inputs such as the active station and the number of pallets waiting in the system, and it outputs an additional delay value that represents how bottlenecks can affect the overall cycle time. The FMU was tested standalone in an external FMI 2.0 compliant environment without being connected to the NX or TIA portal simulation. During testing, different input scenarios were applied, and the resulting delay was monitored and plotted over the time. The test results showed that the delay increases as the queue length grows and increases further when the active station represents a bottleneck, confirming consistent and expected behavior of the FMU. Although the FMU is not fully integrated into the control loop, it provides a foundation for future performance analysis, as the computed delay could be combined with station cycle times to evaluate throughput, waiting time, and bottleneck effects without increasing the complexity of the mechanical or control model. This concludes the demonstration of the assembly line simulation, the PLC-NX interaction, and the FMU concept and testing performed in this project. Thank you.